Okay, we left off on the other video talking about the two important things to note. One, similarity does not depend on the position of the triangle. So that the triangle may be flipped, it may be rotated, reflected, any sort of transformation can occur to that triangle, but looking at the shape of the triangle, you can still determine the corresponding sides. So you can still see that one side corresponds to the other side. The second note is that congruent figures are also similar, but similar figures are not necessarily congruent. So you could have one triangle and two triangles, they have congruent angles and congruent sides. That makes them congruent figures. They have 3 pairs of congruent angles and 3 pairs of congruent sides. And since they have those 3 pairs of congruent angles, that also makes them similar. But if the two triangles have 3 congruent angles, 3 pairs of congruent angles, but the sides are not congruent, it's still a similar figure, but it's not a congruent figure because it is not the exact same size. So congruent figures are the exact same size, shape, everything's the same. Similar figures are the exact same shape, but not necessarily the exact same size. So, are these triangles similar? And if yes, then what is the similarity ratio? So the first thing we need to do is say, okay, yes or no, are these two triangles similar? So we're going to look at corresponding sides. Now you'll notice that these triangles are not in the same position, but you can kind of see the shape. You can kind of see that this angle looks to be about the same as that angle. So that means that 5 corresponds to the 15. And I can see that the 9 corresponds to the 3. And I can see that the 7 corresponds to 21. So now that I have those, I'm going to pick any two. So I'm going to say, I'm going to do my 3. I'm going to put my small over my big. So I'm doing small over big. I'm going to do 3 over 9, and I'm going to set it equal to another proportion. And I'm just going to do 5 over 15. I'm just going to use that one. So what I'm going to do is I need to know that these are going to be congruent. They're going to equal each other. They need to equal each other. So I'm going to use my cross multiplication. Do my karate chop. So 3 times 15 is 45. And if you plug in 9 times 5, you will also get 45. So we can see that both proportions come up to equal the same thing. So that means that those sides are similar. So we could say, okay, you know what? I think that these triangles are similar. If we look at the 3 and the 9 and the 5 and the 15, and we're looking at, okay, if in fact this is similar, what is my similarity ratio? Since these two sets of sides are equal, what is my ratio? Well, I'm just going to take one of those. I'm going to take the 3. I'm going to take the 3 over the 9. So 3 divided by 9, what is that simplified to? Well, if I divide the top and the bottom by 3, 3 divided by 3 is 1, and 9 divided by 3 is 3. So I'm looking at a similarity ratio of 1/3. That's what I'm looking at for my similarity ratio. So I'm going to check that last set. What I'm going to do is I'm going to take my similarity ratio of 1/3, and I'm going to set it equal to the ratio of my remaining sides. So I have small over big, so I have my 7 over 21. So if I again do the cross multiplication and do my little karate chop there, 21 times 1 is 21, and 7 times 3, 21. And so in fact, these two triangles are similar, and the similarity ratio is 1/3. Don't mind the scribbly, scrawny lines because I'm doing this on my home computer, so it's a little bit, the lines aren't perfect. So let's look at another example. Are these triangles similar? And if yes, then what is the similarity ratio? Again, these are not in the same position. So let's look. Look at your obtuse angle. You have an obtuse angle here, and you have an obtuse angle here. Okay, so we're looking at 7 corresponding to 10 because they're opposite that angle. And then 6 is going to correspond to 4. And 6 on the other one is corresponding to 9. So now we can set up our proportion to see. So let's start with 4 over 6 is equal to 6 over 9. Okay, so we're going to do our cross multiplication. I don't know why my pen's acting. So plug into your calculator. What's 4 times 9? 36. What's 6 times 6? 36. So those two pairs of sides are similar. They are proportional. So now let's figure out, okay, now that we know two sides, let's look at those two sides and determine what is our similarity ratio. So I'm just going to take 4 over 6. What can 4 over 6 be simplified to? If we divide top and bottom by 2, 4 divided by 2 gives us 2. 6 divided by 2 gives us 3. So we're looking at a similarity ratio of 2/3. So if I take, again, I'm going to take that similarity ratio and I'm going to set it equal to my remaining set of sides. So 2/3 is equal to, and my set, 7 times 10. Cross multiply. So what is 10 times 2? 20. And 3 times 7 is 21. Well, 20 and 21 are not equal to each other. So we have two sets of sides, so we determine that, okay, do this. So we determined that, so we were able to determine that 4 was proportional to 6 and 6 was proportional to 9. But the remaining pair of sides, 7 and 10, are not proportional. They are not proportional to the 4 and the 6 and the 6 and the 9 because our similarity ratio of 2 over 3 is not equal to our ratio of 7 over 10. So no, these two triangles are not similar. So you can't just find two pairs of sides. If you are determining similarity based off of side lengths, you have to make sure that all three pairs of sides are proportional to each other. You cannot just do 2, because if we had just done 2, we found that the two pairs of sides that we did first were proportional, and we could have said, okay, well, there's two sides proportional, they're similar triangles. Well, they're not. So you got to make sure that you don't stop halfway through the problem. Okay, so now we need to solve for the variables that would make the triangle similar. We have 3 variables. We have x, y, and z that we need to figure out. The first one, and probably the easiest one that we're going to look at first, is going to be finding z. So we're going to find z first. Notice that you have this angle is congruent to this angle. That's given. And that this angle is congruent to this angle. So you've already been given that 2 angles are congruent. So that third angle has to be congruent. Well, if you have 38 here, what is z going to be equal to? Z is going to be equal to that third angle in the second triangle. So z is equal to 38 degrees. That's simple. So now that we know we have all 3 angles inside the triangle congruent, now we're going to look at our side lengths. So we have a 6 and a 10. We have one set of corresponding side lengths already given. So that's going to be the first step of our proportion. We're going to set up 6 over 10. We're going to set that equal to one of the other pairs of corresponding sides. And I'm starting with my smaller triangle and putting my smaller on top, my bigger on the bottom. So let's look at, we have y. Let's put y on the top of our small. Well, y corresponds to 20. So we're going to put 20. Then we're going to do our cross multiplication. So doing our cross multiplication, we have 6 times 20, which is 120, equal to 10 times y, which is 10y. Then to get the y alone, we're going to divide by 10. 10's cancel out. Well, 120 divided by 10 is 12. So y equals 12. So this remaining side is 12. I don't know why it's doing it. So y equals 12. Now we're going to do the same process to find x. X corresponds to our 9. So we're going to set up 6 over 10, and we're going to do our small, which is 9, over our big, which is x. And again, cross multiplication. We're going to do that karate chop. 6 times x is 6x. 9 times 10 is 90. So then we're going to divide both sides by 6. So that cancels those out. Then what's 90 divided by 6? 90 divided by 6 is 15. So now we have our x, we have our y, and we have our z. Those three values are what's going to make those triangles be similar, where all three angles inside are congruent, and all three pairs of sides are going to be proportional to each other. Now we have another example. So solve for the variables that would make the triangle similar. Now we have expressions for some of those sides, but we can do it the same way. So let's start with x though, because that's our angle. So we have angle congruent to angle. We have angle congruent to angle. Then we have this x, but we're told by that little box that this is 90 degrees. So that means that x is going to have to equal that third angle, and x is going to also equal 90 degrees. Now we need to set up some proportions. So let's look at this 9. This 9 is going to correspond to the side length that is in between a 90 degree angle and the two lined angle. So wherever there's 2 marks and 90. Well, x is 90, 2 marks, that means that this a plus 1 is going to correspond to the 9. Then we're looking at this 12. The 12 is between the 90 and the 1 tick mark angle. So between the 90 and the 1 tick mark is 4. And then finally, b minus 2 then is going to correspond to the 5. So let's start with finding a. Well, we know that 4 divided by 12 is that's going to be what we're going to use standard to, because that's what we're given. We don't have any variables with the 4 and the 12. So 4 over 12. 4 over 12 is going to be equal to, well, my 12 corresponds to the 9. The 4 corresponds to the a plus 1. So because I have 4 on top, I'm going to have to do a plus 1 on top, because that is on the same triangle as the 4. Same thing with 12. 9 is on the same triangle. So, cross multiply. This one requires a little bit of extra work, because first thing you gotta do is, what is 9 times 4? 9 times 4 is 36. Then you have 12 times a plus 1 in parentheses. So we're going to start by distributing that 12. So we have 36 equals to 12 times a is 12a. And then 12 times 1 is just 12. So then we're going to subtract the 12. We're going to subtract this 12 from both sides to cancel that out. So subtract the 12. Let me get rid of that little mark. Subtract the 12 from that 36. So 36 minus 12 equals 24. That cancels that out, and you have 24 equals 12a. To get the a by itself, you're going to divide by 12. 24 divided by 12, a equals 2. At this point, I want you to pause the video and see if you can figure out b on your own. When you're ready, unpause and the answer will be shown to you. So b equals 1. Now attempt to solve this last problem on your own. Pause the video, work it out, and when you're ready to see the solution, unpause